This is a topic tutorial on heating curves and phase changes. When we heat a solid, we would expect its temperature to rise proportional to time as it becomes a gas. However, there are certain exceptions and we cannot simply draw a linear graph. This is a typical heating curve. On the y-axis is the temperature in degrees Celsius and on the x-axis is the time in minutes. We labeled the specific points A, B, C, D, E, and F to refer to the graph more easily. First of all, as the substance moves from A to B, its temperature increases. All the increase in heat energy goes into kinetic energy that speeds up the motion of molecules. This is basically the solid heating up. The movement from B to C is where it gets interesting. The substance is still heated, but the temperature doesn't increase. How can this happen? This is when the heat that goes into the substance, instead of increasing kinetic energy, does work to break the bonds between molecules to reach a more disorderly state. This section of the graph is called a phase change. The potential energy increases and the substance changes its state. The temperature does not change in these periods. At point C, the substance is fully liquid and now starts heating up to point D. Temperature increases and thus kinetic energy increases. This section is the liquid heating up. From D to E, another phase change occurs. This is vaporization or boiling, where the liquid turns into gas as heat is added. Once again, at E, the liquid is fully vaporized and the temperature increases as the gas travels to point F. This is the gas heating up. The reverse process is also possible. If the substance is cooled down from the gas state, the reverse pattern occurs. Moving from F to E, the substance loses kinetic energy and thus the temperature decreases. The gas is cooling down without changing state. From E to D, the substance turns from gas into liquid. This is a phase change called condensation. Temperature does not change and potential energy decreases, creating a more orderly state within molecules. From D to C, the liquid is simply cooling down. Kinetic energy decreases and temperature decreases as well. From C to B, liquid turns into solid and this process is called freezing. From B to A, the solid cools down. Kinetic energy decreases because the mean speed of the molecules is decreasing.